agriculture space. So, all right. Yeah, so we've got a few questions, or I've got a few questions. Then I'm going to get an iPad for virtual questions, and then also invite folks to come up to the microphones for questions they might have. But let me kick it off with 2 or 3 questions for our esteemed panelists. So maybe the first question for Alex, in terms of kind of space nuclear and the efforts that you all are attempting to do, what are some of the most significant challenges to adoption, you think, of space nuclear?
That's a good question. So I think historically one of the big issues is just that the technology was not quite there. And that's something that if you look historically at the nuclear sector, we've never had a competitive nuclear energy sector. There was 1 or 2 major US companies and they did all the terrestrial work. And so we didn't have any sort of innovation ethos in the industry. That's changing now because of climate change, because of the need to reduce emissions. There are actually dozens of startups in the US now working on those problems. And now that's starting to spill over into the space nuclear side. So just at the very beginning, a cultural innovation thing, that's now beginning. Beyond that though, the way that I really think about it is startups are about reducing risk. And for any space nuclear company, or really any nuclear company in general, I think you have 5 things. 1, you've got that technology. 2, you've got the fuel. Nuclear fuel is specialized. 3, you have facilities. We have very special facility and safety requirements. 4 is regulatory, where I really am focusing a lot of my work. And then finally, just making the business model of all of that close. Each of those you need to kind of address in parallel to be successful. And I think that, especially historically, that we just have not had as many types of missions available now across the defense, civil for NASA, and commercial sector. So there's now actually enough market for us to be able to go out to venture capitalists, raise enough money, and start addressing each of those questions to be able to get to market.
All right, thanks. Next for Gary, in terms of the bold mission your company is attempting to do in terms of a private mission to Mars, two questions following from that. What are some of the biggest technical challenges that you're facing in that mission, and then what support would you like from government entities to enable that kind of your commercial roadmap? So,
thanks, AC. So in terms of technical challenges, I would say we're facing the same technical challenges that NASA did when they first tried to get to Mars. We're not trying to reinvent the wheel here when we're going there. In fact, we're trying to use as much of the technologies as possible that are translated directly from what NASA worked on. So we actually have a few Space Act agreements worked on with NASA so that we can take some of the technologies, such as the inflatable heat shield to enter the atmosphere, looking at some of the GNC techniques to get in, and just trying to reuse as much of that as possible, because there's already tried and true proven ways of doing this. We want to do it in a very, for lack of a better way of saying it, a SpaceX fashion, because a lot of our company, maybe over 70% is ex-SpaceXers. We're bringing that vertical integration in-house to do that as cost effectively as possible. And we want to do this at low cost as well, because Mars missions are expensive. They are typically Class A missions, hundreds of millions of dollars, if not billions of dollars. We want to lower the cost of access, not just to space, but to Mars as well. So in terms of help from the government, I think there's a lot of knowledge that can be exchanged there, and we already appreciate a lot of the discussions that we've already had with NASA. But I would say even beyond NASA, there's help we could get from other agencies as well. There's the regulatory side of things. There's FAA, FCC, and even international entities that might be interested in going to Mars. So my thought is we should open up the dialogue about what we need to get done on Mars, and how commercial should work with government going forward.
All right, thanks. Next one for Marshall. Marshall, assume you're successful in low Earth orbit, everything works out, and you're sipping champagne to your successful attempts in LEO. How are you going to use that beyond LEO as you're thinking kind of your roadmap to Voyager?
Well, I hope I'm doing that champagne in the station.
Oh, you can do that too.
Yeah, so LEO is really important for where NASA and where we're going in deep space, the world is going in deep space, because, like I said, it's days away. The moon is days away, but LEO is minutes away, really. And you want to test your systems out. You want to make sure that you have a real closed-loop system that works, because they perform differently in microgravity than they do on the ground. You want to make sure that your systems will work for long duration. When you leave to go to Mars, you're going to be gone for years. And there's no two ways about it. You have to make sure they work properly. So testing those systems, correcting them, making sure you're doing training. There's some microgravity training you want to go do. All of those things we need to do in LEO. And that's what I expect to have happen as we move forward. And then, of course, we're involved as well in going to cislunar communication systems, things like that, as we want to build up those capabilities as well.
All right. Maybe a question that I got virtually is, and maybe for our audience, and each of you hopefully can quickly answer this, we've got a lot of young folks in the audience. What are their unique strengths that you're observing from this younger workforce in the industry that's kind of helping to push the boundaries? Maybe to each of you from your perspectives.
Okay, I can start. So I think I'm still young, so I can provide a unique perspective from that side. I made a few career changes throughout my life. I started out doing astrophysics as an undergrad, and then I switched to aerospace engineering for my PhD, and then now I'm in business development. So I've swapped to quite a few different areas, and I think that's what's special about the young generation right now, is that you have the flexibility, the agility to be able to try a few different things from all the areas that you can see in the space industry. You don't have to work in engineering your entire career. You don't have to work in policy your entire career. You can jump in between all of these and basically try it out at a variety of either commercial companies, government, or even defense. And there's just so many players in the space industry today that I think you have a lot of options, and you should take advantage of it and have those different perspectives in wherever you end up going.
So from my perspective right now, one of the things I think is really interesting is that the space and nuclear sectors are very similar in a lot of ways, and particularly when it comes to workforce. One, you have a very stark age, essentially, gap that because of how things developed in both sectors, you have a lot of people in their 50s and beyond that are essentially the old guard that are kind of in the end stage of their career. You have a lot of young people in their 20s and 30s, and there's kind of a big just gap in the middle. We don't really see a lot of leadership from like kind of the late 30s to early 50s. There's just a missing workforce gap, and as we see a lot of retirements happening, we're losing knowledge transfer across both industries, and that's something that I'm pretty concerned about. But what it means for younger workers is that there's a leadership opportunity to kind of start filling a lot of those gaps, find some of those new areas. The other thing I think is really important for both industries is that we're not particularly diverse industries. We have a lot of historical issues with gender, with class, with racial minorities being able to freely participate, and that's something that I think the young generation in particular does not tolerate any of the things that led to that happening structurally, and that's something that I really hope that as people start entering the workforce, that even within other companies or industries where that might be challenging to push, it's really worth fighting for, and that's something that we, even as a young company, we see it's very hard to try and make sure that our company reflects broader society, but it's something that we're committed to, and we hope that young folk are going to be a change force that they demand to work at those type of companies. We see that as really important.
Yeah, I think Gary and Alex are right on the point there. What I would say is, I think because of that gap, you have the opportunity to bring ideas that people maybe who are kind of stuck in their ways are not willing to make those suggestions that say, oh, well, we tried that in 1935 or whatever, we're not going to do it again. You guys bring innovation to the idea. You're not afraid to risk somebody saying, no, that's not good. You just put it right out there, which I think is amazing. If you go back and look at Apollo, the average age of the Apollo person working on the Apollo program was 28 years old. So you had people that were in their low 30s who were running major parts of the Apollo program and the moon system. And a lot of those things happened because people weren't afraid to say, yeah, we're going to try it this way, and we're going to figure it out, and we're going to test it, and we're going to make it happen. So I think that's one of the biggest things. Also, your willingness to jump around, which is kind of what Gary was getting at, that, hey, this is not working, let's do something else. But I don't think of it in terms of jumping jobs. I would rather have somebody come and work for me. But they're willing to jump ideas. They're willing to jump to different sectors of that workforce so that they can hopefully add value to the program.
Another question kind of on infrastructure. A lot of your kind of infrastructure plays in different ways for the products and services you're looking at. Can you speak to how those products and services are going to enable this deep space exploration future that's going to need services and missions, but also infrastructure? Maybe how you're playing in this whole infrastructure kind of game for deep space, maybe.
Well, I'll go first. I mean, we're in the infrastructure business. We're building stations for service. We're building comm and power systems for service. We're building, looking at how do we go build oxygen and water and fuel systems on the surface of the moon as a service. So we actually think that is what is needed. It's what the government is wanting as well. I mean, most of the contracts that have come out in the last 5 or 10 years have all been services type contracts, including going to the moon. This one and the current one coming up, that SLD, Sustained Lunar Development, is coming out. So that will help engage commercial and will also help get the cost down. And that is how we get to sustainable. That's how we keep going back. And once we find out how to do nuclear fusion and we actually can make that happen, then we can get H3 very cost effectively from the surface of the moon, and it changes the world.
From my perspective, we're definitely an infrastructure play, and that goes to really some of the architecture stuff I was discussing during my lightning talk. But I think if you think about space nuclear as one thing, it's an enabling technology. It doesn't necessarily compete with solar or chemical in most applications. And I think that that's something that there's a difference between we're trying to compete in an area that exists. When it comes to the moon, we're talking about enabling technologies that all build upon each other. You need to have communications to be able to do any of this. You need navigation services, you need power services. If we actually get to the point of having astronauts, I think frankly you're gonna need rescue services. You're gonna need things that we can't even think about right now. And one of the reasons that I'm really passionate about working on the power side is that we can kind of address each element of the base of those services, that if we have that power in certain areas that otherwise you can't use it, that enables so many more things that we can't even imagine.
From the impulse space perspective, we focus on the transportation infrastructure, and I agree with all the points that Marshall and Alex just made. We're a big fan of firm fixed price contracts. I think doing things as a service as well, it's the way we need to move going forward. We want to do things cost effectively so that we can get to that sustainable transportation infrastructure that we need. And for example, one of the things we think about is how do we develop the commercial superhighway to Mars? In the past, it's always been government, NASA missions, dropping off rovers, helicopters there, and a lot of times they start with the payload and then design the transportation mechanism around that. So you ask, what's the payload first? What we want to ask is, what payload can we put on our transport vehicle? We want to make it agnostic to the type of payload that you put on there. So we're developing the in-space transport stage going from the Earth to Mars, the entry stage, and then the lander. And we're going to customers and asking, all right, now that we have some of these interfaces, what do you want to put on our vehicle? So we're trying to redesign how the infrastructure is done for transportation, not just for Mars. This can also apply to transportation around the Earth as well. So when we're thinking about this infrastructure, we're trying to make it as flexible as possible so we can get to that sustainable economy that we want in space.
All right, and my final question, we've got 2 minutes. I am giving you a meeting with the President of the United States. He can make one phone call for you, either to someone in the government or someone in commercial industry to do something for you. What do you ask the United States President to do for your company?
Wow. I don't know. There's several calls I want him to make, him or her, to make. And I think one of the things that we are facing as an industry is how do we deal with commercial space working in this regulatory environment? Who's running the system? Who's in charge? Do I go to the FAA? Do I go to NASA? What standards do I have to follow? It's kind of a mess. And I would honestly think that we need to work that out, and soon, because we're about to enter into this world where we're doing truly commercial work, and we're going to need to understand what that legal landscape is and that policy is. So that's one non-issue, one issue that we need.
So regulatory is really good. I think Marshall did a good job of covering that overall. I think from my perspective, really the big thing is sustained demand. And I think that that's something that we have a really good sense of where NASA wants to go. We have a really good sense of where the commercial companies that are supplying NASA wants to go. But part of that is without very clear established appropriations and funding, that's really hard to be able to say, hey, we see this lunar economy, and a VC is going to say, yeah, but that doesn't exist yet. And so being able to really have something that's clear that can point to, no, Artemis 5, Artemis 6 is paid for now, and we also have all these other things that are off budget, that would be ideal. But until then, I think that a lot of the companies are really planning that we are making a bet that that future will materialize when it comes.
My perspective, I think the best thing I would ask the president is if they could start creating firm fixed price contracts to start just doing moonshot challenges. For example, I don't want to speak just from the impulse space perspective, but more space logistics as a whole. Let's say active debris removal. I think it'd be great if they just created a large pot of money, hundreds of millions of dollars, and said, go deorbit this piece of debris for us. Right now, there's a lot of development programs and studies, and I think there's a lot of progress that are being made right now. But I'm going to use the SpaceX mentality again. I haven't worked at SpaceX, by the way. I'm going to use it again, just because we talk about this a lot at Impulse, is we'd like to just go and do it. And we want to do it at a low cost and be able to do it as fast as we can. And I think right now, with a lot of the contracts that are in play, there's this chicken and egg problem where we want to go and do something, but there's no money for it. So we have to wait for it to get pushed through Congress to create a line item in the budget, and then be able to develop a program, and then ultimately be able to do something. So not talking about any specific area in space logistics, but as a whole, we need to solve this chicken and egg problem. And I think if the president just said, here's a pot of money, go do it, I think that'd be great.
All right, well, thank you. Well, let's give a round of applause to our panelists for this panel.